Hello and welcome to the next lesson here. And today's topic for this particular lesson is scatter plots and linear correlations. So our learning goal today, I can critically assess a scatter plot, which means that I can look at a scatter plot and I can identify the type of linear relationship and determine what type of linear relationship we're looking at or what type of correlation. So I can critically assess a scatter plot and determine the relationship. And like I said, today we're looking at linear correlations. So moving on. Relationships. So some of the relationships that we deal with in the data management course that we're going to have to be able to critically assess. Does smoking cause lung cancer? Does your height affect your ability to estimate other people's height? Does marks in sports have a relationship? So those are the ideas that we're looking at, and what we're doing with the project is we're collecting statistics to support some of the statements we made in our hypotheses or our theses. So sometimes relationships between two variables aren't clear-cut. You can't just look at the data you collected. Sometimes you have to rearrange them, and we like to putting them into a graphical format to help us develop these mathematical relationships. And that's what our goal is here, is we want to find mathematical relationships with some of the data that we're looking at. So the visual pattern in a graph or plot, it also often helps us to determine the nature or the relationship between those two variables. So a scatter plot is a graphical representation of collected data when comparing two variables. And what's it look like? Going way back to grade 9. We did scatter plots in the unit called linear relationships. We always have the independent variable, our x values across the y-axis and on, the x-axis, and on the y-axis we put our dependent variables or what we were measuring. So when you complete a scatter plot often is a series of dots. And those dots help us to determine the type of relationship. And for the dots that I've drawn, sometimes we'll get a dot or two dots that seem to fall well outside the realm of the norm. When you look at the ones I've drawn, the majority seem to fall within this particular corridor or region. So these two dots here are what we would call outliers. So someone read the dial wrong, someone click the stopwatch wrong. They're data that does not really fit within there. So it helps us to identify or make it easier for us to identify outliers or pieces of data that don't fit. So some terminology that we need to review quickly, and most of these you've seen. Independent variables we've been talking about with the project itself. Variables that you can control, or they're the factor that we're investigating within the investigation. So cost of tickets you can control, time you can control. Those are variables that you have the ability to control. Dependent variables. Okay, these are variables that cannot be controlled and they are affected by another variable. So the number of people that attend a concert, well, it depends on cost of tickets, how many seats are available. There's a whole bunch of factors, location. So the dependent variable here, number of people that are attending, all depends on other variables. Height of a falling object. Okay, depends on how much time has passed, where it started from, and so on and so forth. So those are the two main ones, and we've talked about them already with the project, so we're revisiting them here. Correlation. This in grade 9, you know correlation as relationship, and that's simply what correlation means. So we're changing to a grade 12 vocab, specifically in the data management. When we talk about correlations, well, it's the mathematical relationship. So exactly how it was in grade 9. What is the relationship between this and that, or x and y? That's what we're doing here. So we're looking at the relationship that exists between two variables, resulting in a mathematical model. And that's what our goal is we want to develop mathematical models. Linear correlation. Linear correlation is the relationship between two variables that results in a line. I know, complete shock. You didn't see that coming. So the representation, when you do the scatter plot, it looks like the data follows a linear pattern, or a line can be drawn. And from that, we can get a mathematical model. And that mathematical model, going way back, and I know there's some people that are screaming as I pull this from the depths of the depths of their brain here, but y equals mx plus b, that was the equation for a line, and we're going to be revisiting that a little bit. And finally, line of best fit. I know for certain we do that in that grade 9 course, and that's when you are drawing a line that passes as close to as many points as possible within the scatter plot. The difference in the data management is now you need to have some critical thinking skills and identify outliers and say, hey, that piece of data is no good. I can't include it in my model. Someone didn't read the gauge right, or someone answered completely outside the acceptable limits here. So that's where that critical thinking skills come in. So for some of you, especially the ones that had me in grade 9, this is going to look very, very familiar. Classifying linear correlations. And I have the 6 major ones that we talked about in the grade 9 course, and it hasn't changed. One quick review here. We were talking about the line. So just a quick refresher on slope. Remember that we have 4 types of slope. So we have the slope, the line going up to the right. We have the line going down to the right. We have the horizontal line. And then we have the vertical line. So I said slope in grade 9, slope is always the exact same the way you read a book. You read a book from left to right. So starting on the left, we're going uphill. And if you are going uphill, we call this a positive slope. Positive slope, which means that if you are going down a hill, as you read again, left to right, okay, we have a negative slope. The mathematical reasoning behind this, as you move, if I go back to the positive slope, as we move to the right, we are going on the positive direction on the x-axis. And in order to follow the line going upward, we're going in the positive direction of the y-axis. Over here, for any point on the line, as I move to the right or in the positive direction of the x-axis, I have to move in the negative direction of the y-axis. So that's why we have the positive and negative slopes. So for the third one down here then, as I move, if I follow the same reasoning, the positive direction of the x-axis, I'm not going up or down, so this is our 0 slope. Okay, remember with the toboggan, talked about ski hill. Okay, positive slope, a lot of work. Negative slope is a lot of fun. 0 slope is really, really boring because you don't go anywhere. And if you're a skier on a vertical slope, it's absolutely terrifying because you plummet to your death. And this is an undefined slope. We don't like skiing on undefined slopes because they cause death. So there we are. So those are a quick review of our slopes. I'm more interested in positive, negative, and the odd time we'll get into a 0 slope, but for the most part we're looking at 1 and 2 there. So back to this chart that we'll fill out quickly. Your line of best fit, and this is an exaggeration. You got to keep this in mind when you're doing your own statistics, and I'll talk about this in a second or in the next video. So in this case, put a ruler on it. I don't have a ruler. I'm going to use the software to help me out. So there's my line of best fit. I, of course, did it with a ruler. So there's my straight line. So I asked myself, first of all, how good was the data? All the points seem to fall on my line. So every point in the data seemed to move or fall right on my line. So that means that the data was very strong. Very, very strong. It's a negative slope. It's going downhill. So a strong negative correlation. So that is the statement I'm looking for. And we talked about this in grade 9. It was on the exam. We called it a strong negative relationship. That's the only difference. Similarly with the second one here, take your ruler, draw a line through. It's actually fairly straight. And this one here, the data points are close. They're all fairly close to the line. But we would call this a weak negative correlation. Now, I'm going to talk about how can we mathematically measure this, because it is subjective, and I said in the grade 9 course, I said I would make it exaggerated, but how are we going to determine it now when we need to be a little bit more accurate, and we'll deal with that in the next video. Finally, I'm looking at this third one here, and I'm trying to decide where to draw my line. So the question is, which direction is my line going to go? If you have to think of it, this is the rule of thumb, if you have to think about where does that line, where is it going to be drawn, like this or like this, if you can't figure it out, that probably means that there is no linear relationship here. Okay? No linear correlation. Sorry, got to go back to grade 12 terminology. Correlation. All right, so there's no linear correlation. And finally, looking at D and E here, you start to see the trend. So I draw the line. Again, most of the data points, or all the data points, fall on the line. It is now a positive slope, so we have a strong positive relationship. And so we have a strong positive, should be correlation, not relation. Correlation. And then the next one, oops, again, the data here. Oh, I put arrowhead on, it won't work. Okay, it's not quite as good, so we're going to call this a weak one. And again, you don't have to worry about, I'm going to talk about how to deal with, is it strong, is it weak, because over here in D part, this is fairly ideal. I mean, you're not going to collect data like that looks like that very often, unless it's a grade 9 staged experiment where I want it to work out. The data we're going to be collecting is going to be more like this data here, so it's now how strong is that, and we're going to talk about that in the next video. So, it's weak positive correlation. And finally, the last one. In the grade 9 course, you had to identify it as, hey, that's not a line, so you told me it was nonlinear, and that hasn't changed. Nonlinear correlation. And we're going to talk about specific ones and how you differentiate between the different types of nonlinear. So we'll get into that as the lesson, or in the next couple days. So anyhow, there's the first part, and I will show you some examples in the next segment.